Good afternoon, folks. All right. We're going to continue our discussion and examples of SQL today in Replit. All right, so let's pull that up. So last time we were looking at some examples using the database from the assignment. And that was SQL1 exercises. Okay, so I've pulled that up here. Pull up the chat here. All right, so what we want to look at today is we're gonna finish off the SQL Part 2 slideshow. We only have a few things to go over here, and we finished off with looking at the foreign key constraint and how that works to prevent records from referencing nothing. So, you know, foreign key field in a table references the primary key in another table, and that's how we represent a relationship in relational databases. And so you can do that without using a foreign key constraint, but it won't be able to prevent problems from occurring, such as adding a record without checking to see if there is a record that it references. So in this case, you know, adding a course to a department that doesn't exist, it'll prevent that, and it will prevent us from deleting a department if there are courses in that department. So those would both cause problems. All right. But we're going to shift gears now, because I'm pretty sure we've talked about each of the constraints: default, foreign key, primary key, unique and not null. We already talked about in database in the design part. Preventing fields from being null or forcing them to be unique. So we're going to move on here. We're going to talk about something called views and how to create them in SQL. So I'm going to copy the exercise example so we don't have to rebuild a database, and then we'll use that as our example. So I'm going to copy this, and I will call it SQL Views example. I'm going to go ahead and post this in the chat so you can look at it later. All right, so what are views? It says a view is a virtual table based on the result of any SQL statement. Okay. A view contains rows and columns just like a real table. So a virtual table has everything that a real table has, It's just not stored anywhere in the database. Okay, so what does that mean? Well, we can see an example of that here where we're using select statements. Okay. So I'm going to get rid of some of the stuff we did last time. If you need to look at that, it'll be in the previous example. But I will keep this part because this select statement uses something called an inner join to combine two tables so that we can see the data from both in a different way, right? So we're looking at courses and departments in this result because we are creating a view or a temporary table that shows us how those are tied together. So actually, let me bring back, if we just print out department and we just print out course, that is right here. Here are the departments. All right. And then here are the courses. All right. And it says the biology or Bio 101 is under the biology department. All right. And over here, biology, it says what building it's in and what their budget is. So let's say we want to add, let's say we want to generate a list of courses that a student has and also add what building those are in. Okay, how would we do that? Well, right now, let's just focus on making a list of courses, or where each course is, right? We want to know what building each course is in. So if we just print out these two tables, we can see from this table, Bio 101 is under the biology department, and we have to look at the other table. The biology department is in the Watson building. So we could print out both of these tables and let people cross-reference it, but that would be a nightmare, right? Because what if there are more departments, and this is definitely not a comprehensive list of courses here. It's just kind of a small samples that we can mess around with the data. Okay, so last time I talked about this a little bit, but I want to go into more detail about what a join is. So I'm going to turn these off because we don't want to print both tables and then manually cross-reference the data. We're going to make the computer do that for us. All right, and let's go ahead and comment out this. Copy it down, and I'll comment this out for now, so we can reuse this after the example I'm going to do now. Okay, so this is the proper way to combine the data in those two tables. See what that looks like. And if you're not seeing it, go ahead and clear your console. All right, so now we have this result, which is a temporary table of course titles and building, the building where they are in. So world history is in Painter, game design is in Taylor, genetics is in Watson, and here we've limited it just to the course titles and the department buildings. So you can see here we're selecting two columns. Right? Because in the select statement you list the columns that you want to show in your result. So we have one here, and then we separate them with a comma. Here's the second column. So in our result, we'll have two columns. And it's pulling the information from the course table and the department table. It's pulling these fields. So this dot notation here is table dot field. All right. And do you remember what we put in the from? This is where you list the table that you're using. And if you look back up here at these simpler ones, we are selecting all the records, that's what this asterisk is, from the department table. So the from is where you list the table you want to pull your records from. But down here, since we're grabbing records from two different tables, we have to join those tables properly using the primary and foreign key so that we can pull data from both of them, accurate data. All right, so if we do it this way, so instead of doing a join, let's just list the tables. Okay, so from course and department. All right, let's see what we get. So take a look at this result over here and tell me if you can see something incorrect. There is something very wrong with this result. Okay? Why do we have the Intro to Biology course listed as being in every building, and the genetics course is listed as being in every building, and every course here is being listed as being in every building? So if you just list the tables that you're going to pull the information from, what it actually does is it just takes every record from the first table and matches it with every record from the second table. And so if you want that, this is how you do it. But that's not what we want. We only want the building that each course is in. So this is useless to us. So how do we properly connect these tables to get our result? So instead of just listing them with a comma, we have to tell it to join those tables together. And for now, in this class, we're only going to worry about one type of join, and that is the inner join. Actually, if we skip ahead to part 3 here, I was going to draw this, but I actually have a slide for it already. There are multiple different types of joins that you can do. The main one we're going to use is inner join. So, but I do want you to be aware of the other ones. So, what happens here if we list both? Well, it looks like SQLite doesn't support the full outer join. So let's not use that as an example. MySQL does. All right. So anyway, these are Venn diagrams that show you what records are going to be included in each type of join. Okay. So with an inner join, we can see this circle here represents every record in table 1. This circle represents every record in table 2. And the part that's filled in as green is the records that are going to show up in our result of an inner join. And so where this overlaps is where the primary keys and foreign keys line up. All right. So in this case, where we only want the courses that are in buildings and we only want buildings that have courses in them, we want to use an inner join. Okay, so in this case we're going to use an inner join. Okay, in the case of using well, it doesn't let you use a right join in here, but let's see if it allows a left join. So this was an example of what we don't want. I'm just going to get rid of it now. But a lot of people try that. They try to just list the tables, but it doesn't do anything useful. Okay, so here let's try a left join. All right, and let's compare that to an inner join. So we can see if there's any difference. So our left join has 14 records. Our left join has 14 records. So they're the same. All right. And so what is the difference? Well, we don't have data that can show us what the difference would be here. So let's add some. So let's insert a record into courses. And gotta remind myself what all the field names are in course. So I'm just gonna print out that table. There is course ID, title, department name, and credits. So let's give it course ID, title, and credits, but let's say it's not under a department. So to do that, we would say, okay, insert into the course table these fields: course ID, title, and credits. All right. And we'll put in one record, and we'll give it a course ID of Fun 101. Okay. And let's see. We're going to print out 3 results here. We're going to print out everything in course in the course table, and then we're going to print out a left join between the course and department table, and we're going to print out the result of a inner join between those two. So clear that out and run it. So we have an error. 294. Oh, I forgot to put in the title and the course ID. So we'll give it a course ID of, oh, we did put the course ID, but we didn't do the title. Fun stuff. And we'll give it the credits of 1. It'll be 1 credit course. All right, there we go. Clear that out, run it. Okay, so we have Am I printing it out twice? I am. Whoops. Okay. Don't want to print this one out. So we're going to insert that new record. Then we're going to print out the course table so that we can see that it got inserted. So here's Fun 101. It's called Fun Stuff. It's not part of any department, and it has 1 credit. All right. And so now, let me see if we can differentiate these. I think in the previous example, we were able to enter in some of our own output to kind of make it easier to read. I don't remember the syntax for that, but I know where to find it. All right. So here we go. We were doing, oh, that's simple. We just print out the result of a table field. So we can put this here. We can do select left join. Let's see what that says. See if that works. So that puts that here. And what we're using for some blank lines, this right here.
Salmon oil in there and stuff.
Huh? And we'll put left join, just so we can label these so you guys can see which one is which. So that should look like this. So here I've labeled, here is the result of our left join, and here is the result of our inner join. All right, and so if we look here on the left join, we have fun stuff, and it shows no building because it doesn't have a department. Down in the inner join, it does not show fun stuff. So, why do you think the inner join is not showing fun stuff, but the left join is showing it? If we go back to the diagram, all right, remember, the inner join only shows the records that are matching on the primary key and foreign key, okay? And that will only happen if you specify the foreign key and primary key. So let me take that off. So here we're saying join course and department using a left join. So course, left join, department, okay, on, and then this is where you list the primary key of department. Department name is the primary key, and we also have department name in course. All right. I think in some SQL, if you give the foreign key and primary key the same name, it can detect that, but you don't necessarily have to name them the same thing. They just have to have the same data type. So let me try taking this off and see if it still works. In SQLite, because I have not tested this in SQLite. Alright, and so it looks like it's not working. Because we're not specifying what the primary key and foreign key are, it's doing this. And what is this? Well, it's listing every course as being inside of every building, which is nonsense. It doesn't mean anything. So here we do have to specify the primary key and foreign key in both a left join and an inner join, because otherwise it doesn't know what this part in the middle is. We're defining where the tables intersect. Okay, so in an inner join, it only shows the records that actually have the primary key that matches the foreign key. A left join shows every record in the first table, but only the records in the second table that match the records in the first table. And so that is why a left join, let's fix it back to the right result here. That's why a left join includes fun stuff, because it is a record in the first table, but it doesn't have a department, and so there's no way for it to find the building. It doesn't have a building, but it still gets included in the result. So if you wanted a list of every course, even including ones without buildings, you would use a left join. If you only wanted classes that were in buildings, you would use an inner join. Okay, so very minor difference there, but it makes a big difference if you want one or the other. Because if you think you're getting what a left join gives you and you're doing an inner join, you're missing a lot of data potentially. Okay, so those, like I said before, knowing the difference between these is important, but in the class I only need you to be able to demonstrate how to use an inner join, because that's going to be your most common type of join. There are situations where left joins are important, okay? And then it says in SQLite they don't support right joins, but if you just reverse the order of the tables, let's see if that works. So let's say we want to list every building and then only the courses. Wait, that doesn't make any sense. Maybe. Well, let's see what it does. So let's join department. Oops. Let's use, let's use the left join for this one. Department, left join, course. Let's see what the difference is there. Alright, so that's this left join here. So it looks like it's always going to put the table with the foreign key on the left, apparently. So I don't think it actually changed anything. Let's get rid of the course output here. Because that way we can see this as the top result, so we can see if it's any different. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 records. I'm sure there's a way we can have it. Oh, there is. There is a way we can have it count the records. And we'll actually look at that in the next chapter. So for the sake of time, I'm just going to use it, and then you can learn how to do it when we talk about it. So I want to select this again in here, but I don't want to grab those fields. I just want to count how many there are. So I can do count star. Okay, and let's see if that works. Or if well, the syntax might be different in SQLite. Okay, there it is, 14. Okay, and so we can use that same thing down here in the inner join result. So that we can count those. We'll put a little message here. Records. So while you're watching this, you need to be able to look at one of these select statements and interpret what is going to print out. So clear this, and we'll see. Whoops, I forgot to print out, or make it a string. There we go. So it's getting mad because it couldn't find that. And there we go. So in the left join result, we have 14 records. In the inner join result, we have 14 records. And so here we've flipped department and course. Let's flip it back. In the left join, so we'll do course, department, there, and we got to do it here too because this is where it's counting it. All right, and so in this case, we're getting 15 records, so it is making a difference, because whichever one is first is considered the left or the first table, right? So table 1 is always going to be whichever one you listed first. So even the order of the tables that you put in from matter. And so the reason I'm showing you this is if you just flip the order of the tables, it's going to change from a left join to a right join. That's probably why they haven't implemented that. It's just a shortcut. And then you can't do a full outer join. Now I'm trying to figure out why it wouldn't let you do that. So that would show you all the records on this side, that aren't part of the middle, and where they link up. So if it's not going to let us do it, we'll just forgo that. I wonder... You could probably do multiple joins to get all that information, but we don't need to. We just want to focus on inner join. Okay. So I'm going to actually change this to joins example. And did I post that in here? And I'll copy this. Oh, now it's disconnecting. There we go. There we go. Okay. So I just broke the first link. Should not have done that, but oh well. So here's that example with the joins, which is important to understand with views. Okay. So we need to fork this. Okay, so I'm going to copy it, and then this will be the SQL Views example. So we're going to get rid of the join stuff, except for we'll keep one join here. We're going to look at creating views now and what a view is. So I had already mentioned a view is a virtual table. All right. So keep that in mind as we go through this. And I'm going to go ahead and get rid of a bunch of this stuff that we don't need. And then we'll see if it works still. Okay. We don't need, well, yeah, we don't need this. Oops. I'm going to see if there's an easier way to do this. Printing the number of rows. Show number of rows in result. Yeah, it looks like you have to manually do it. Okay. So let's just not worry about that for now, because we don't need to count them anymore for this example. So let's take a look at our what we have. So here's our combination of the course and the department table. We're using an inner join, so we're only getting records that match on department name from both tables. Okay, so anytime we want to run this query, so let's say we, here, when we're writing select statements inside of this, what I would call the schema of the database, basically the rules for setting it up, the only real reason to write select statements in here is to test them out, okay? When we need to actually use something like this, it's going to be some sort of software asking the database to pull out this information, so it will do a request to run this query to the database. The database will put it together and send it out to wherever that's needed, wherever it's asking from, okay? And so these aren't going to be hard-coded in. You know, we're not going to write select statements just like this floating around. Plus, we don't want the person developing to have to write queries like this, because maybe they don't know SQL, and maybe they don't know the names of the fields and things like that. So we can simplify it basically by saving this query as a view. So a view is just a handle or a name or a shortcut for running the query. So when you're doing views, you will write the query like this to see that it works. So you'll fine-tune it, and you know, we'd already worked on this before to get exactly what we wanted. All right. So now, how can we make it easier for someone to get this information? That's where views come in. All right. So here's the syntax. We'll just copy this right in and hope that it works in SQLite. If not, we'll just figure out the proper syntax for that. Oh, be careful when copying text out of Microsoft Office programs. There are a ton of extra formatting characters in there. Whoops. So I don't think we'll be copying that. We'll just type it. I've ran into a lot of weird issues with that, so be careful about copying out of the PowerPoint or out of Word even. You want to use a text editor that doesn't have extra formatting characters. Create view. All right, so it's like create table or create database, but now it's a view. Let's shrink that down so we can see what's going on. It likes to scroll up for some reason. Okay, so we'll create view as, so you want to give it a name about, you know, what you're getting. So we'll put courses by building, maybe. That'll be the name. Okay, that's the first part. And then the rest may look familiar to you. What do you think this next part is after the create view? This is a select query. Okay, so we can put the query we were using here. Constantly adjusting this. I wish it would save, but it's no problem. Okay, so we're going to create the view called Courses by Building as this query. So we can just take it here and we'll move it down here. And now when we run it, nothing is output because we haven't asked for it to output anything yet. All we've asked for it to do is create this view. So now anytime we need to run this query, we can do select star from courses by building. And that will always just run the query inside here. And so this query right here is fairly simple. It may look long, but queries can get extremely long for grabbing specific information from a lot of different tables with a lot of different records. So we created a view, and now if we want to grab any information out of it, we can just use the name of the view. And let's say we want specific information out of this result. So let's say we want to see the titles of the courses and the buildings, but let's say we only want to see what courses are in Taylor. We can do a where clause on the view, where building equals Taylor. Alright, and that'll give us the result from, it'll run this query and it'll generate the entire table from this query, and that will be filtered so that it only shows the results where building is Taylor. And so anytime you want to write a more, use a query like this, but just take specific information out, you can see how much easier it is to just use this. So maybe we want to look for the ones that have Taylor and the ones that have Watson, but in separate results. So first one is grabbing all the records from Taylor with building of Taylor. Here's the ones with building of Watson. And we don't have to copy this whole long query and add in where on that, because we save that as a view. So anytime you're going to be calling a query multiple times with different things, different filters or whatever, you can just use the view. And so remember earlier we were printing out the count of records. So we can do that here. Maybe we just want to know how many classes are in the Taylor building. So we don't have to write this whole query again. We can just do this. And we can use an alias to clean it up as courses in Taylor 6. I'm sorry, not courses. Yeah, it is. That's right. courses in the Taylor building. And there's 6. And we could do how many are in Watson? 4. So remember the thing we're showing here is views. So let's create another view real quick. And this time, let's not use a join. Let's take a look at, I'll have to print it out because I can't remember what the fields are, but we'll select all the records from student real quick so we can see what that looks like, and then we can come up with an idea for a query. So we have all of these students with credits. Let's show all the students that have less than 50 credits. Let's say we want to do that. Let's say we have a scholarship that is only available to students that have less than 50 credits. And so we're going to be calling this periodically, running this query periodically to get that list every semester maybe. So we are going to select all the records from student. So when you're creating a view, you should make sure that query works first before you set it as a view. So select star from student, where, and it's called tote cred. Tote cred is less than 50. Okay, let's make sure that works. And touchpad's not working. Okay. I want to make this visible. That's really aggravating. Okay. And let's get rid of our other example here. I'm just going to turn off the number of courses in Taylor. And I want to turn off, oh, so we should just get one result. So here's the list of students with less than 50 credits. Let's say I just want their name and I want their ID and their name. Okay? So I can use that maybe to send out a message to them. So we're going to select the ID and the name. Okay. From student, where the credits are less than 50. And like I said, we might want to run this more than once, so we want to create it as a view. So we can do create view scholarships as this. Okay, and then if we ever need to see that list, we can have the developer just make a call to get the result from the scholarships view. Now to the developer, it feels like they're just grabbing a table out of the database. But remember, that's not what's happening. Because a view is what? It's a virtual table. So anytime you run a select statement in the database, and some of you probably have realized this, whenever you run, if I run a select statement on the database, it outputs, and then what happens after that? what happens to those results? Okay, so it prints this out. Where do you think this information goes after that? Well, I've been calling it a temporary table because as soon as it prints out the results, we didn't tell it to do anything else with it, so it just forgets it. When you do a select statement in here, you're asking it to put together the information and spit it out. All right? And so this is also why views are useful, because we can now save queries as virtual tables. They do not take up any extra space in the database. And when whoever's writing the software needs access to that information, they don't know whether it's a hard-coded table with inserts and anything. All they know is if they select star from scholarships, they get this information. So they don't even know if it's stored as a table or a virtual table, because it doesn't matter to them as long as they're getting the information. And if you're in the programming degree, you're going to see that firsthand, because you'll be doing both. You will actually be designing and creating the database, and you'll be writing the software to access it. And so with a more complicated database, you're not going to want to write, if you're using these queries over and over again in multiple places, you don't want to write this, right? You don't write this multiple times. You just write it once, save it as a view, and then you can access it like this. Okay, so we've got 5 minutes, and we have, in the SQL part 2, I think we have one last thing to talk about. All right, and this has to do with the way data is accessed in the database. This is a database efficiency and speed optimization tool, and that is called an index. So in the database, inside of a table, we have all the fields with all the data for all the records. So for example, on the right here, they have an ID number, a city, and a country. All right? That's really tiny, so let me zoom in. So this on the right, this is the table. And I just realized there is no reference to what these are. So let me just make a little label for them. So this one is the index, and this one over here is the actual table. So we've looked at creating tables, but we haven't created any indexes yet. And so let's say I want to find the IDs of these cities. So I'm going to find the ID of Warsaw from this country's table, or whatever you want to call it, capitals table. Okay, Warsaw. So what the database will do is pull all the records out, every record, and it will filter out all the records that don't have the capital name of Warsaw. Okay, so it has to pull all the records out, go through all of them, and remove the ones that don't have Warsaw. All right. And so here they only have three fields in each one, but maybe this has 50 fields. All right, and so that will take a long time to read all of those records and find it. Here they have an index. It is sorted alphabetically by country. And so if you do a search, in this case, this index is only gonna it's only gonna go by country. So if you search for a country name, and let's say you want to get let me create a new situation. You want to find the capital of Nigeria. Okay, you have this index and you have this table. The table has the name of the capital, the index does not. And so if you have an index, when you say, okay, tell me the capital, so return, I want to see the record for Nigeria. I want to pull all the information about Nigeria so that I can get to the capital, or see what the capital is. Because the index is sorted alphabetically, the computer can quickly find Nigeria and see there is a reference stored with it to the exact location of the record for Nigeria. And so now it doesn't have to grab every record out of the table and search for it. Because we have an index, it knows exactly where it is. So it can say, okay, go to the Nigeria, and it'll know exactly where that is because it's alphabetized. And then it'll check what the reference is, and it will pull this information. And once you create the index like this, you don't have to tell it to use it. It will automatically, when you search for this, it'll use this index to find it quicker. And so by using indexes, you can really speed up the efficiency of your queries. Because it would just be unfeasible if there were, well, how many cities are there on Earth, right? Or I'm sorry, how many countries? And they're changing all the time, right? All right. Whoops. And so to create an index, you use this, create index, and it might be different in SQLite. Let's take a look here. Also, I'm 1 minute over, but I started later today, 10 minutes later today, so I'm going to keep going and finish off this. I don't want to come back to this PowerPoint again. Okay, so create index, yada yada, on table name, and then you provide the columns that you want. So let's say for the, well, we already looked at views. I'm gonna post this one in the chat before I leave, and then I will copy it and make one for indexes. All right, so we have all the setup stuff at the top, and let's get rid of all of this. We don't need this anymore. All right, so which table up here has the most fields? Banana, classroom, department. Courses have a lot. No, they only have 4. Does everything have 4? 7. All right. Sections have the most. So if I do select star from section, all right, we can see that there are a number of fields here. And so let's say we want the record of this one here. I wonder if you can do this. Query time. Oh, timer on. Let's see if this actually makes a difference. And so, for small things, it may be an unnoticeable amount of time that an index will save you. But, and if you remember from database design, what were we trying to reduce? We're trying to reduce data redundancy in the database. If you have an index, what that means is you're storing whatever columns are in the index. That's all stuff that's stored in the table. So you now have a copy of that, an extra copy, which means every time you add a record to that table, you have to update the index. Every time you delete a record or update a record, you have to go and update the index. I mean, the computer has to do it, but that adds extra overhead every time. So you really have to think about this from every variable. Is it, in this situation, is it worth it to use an index or not? So let's turn the timer on and let's see if it says, okay. So here, I think this is in seconds. And I'm not sure. Okay, let's run it again. So we can get kind of an average. So it's taking less than around 10,000ths of a second. There's 1/10,000th. There's 1/10,000th. Yeah, it's about 1/10,000th of a second to run this. Okay, let's see if adding a index makes a difference. Create index. On the table with the fields. Okay. On. Why is there an alter code in there? Oh, that's how you get rid of the index. So create an index, drop an index. Because it becomes part of that table, so that it can be updated when that table is updated. Okay. So this is the section table. So create index on section. And let's see what that does. And then we're going to run it again. See if that makes a difference. This might be too small to even measure the difference here because there's not that many records. Create index on section. Oh, it's probably different in SQL. So, or I'm sorry, SQLite. Or you might not even be able to create indexes. All right, here it is. All right, create index. On, oh, give it a name. Create index. Table. No. This must be database dot index name on table name, and then you give it a column that you want to index on, or a list of columns. All right. So we're gonna create index. Oops, we don't need this anymore. Okay. And go back down. Keeps putting me at the top. Create index be on section, and we'll go, we're searching, oh, we're just selecting them all. So let's do it on the primary key, which is, what is the primary key of section? I think it's section ID. Yeah, no. It's probably the combination. Well, we can see it's right in here. I think it's a composite key. So create section. So I'll just search section. So it says the primary key is, oh, because this is a joining table. It's got all 4 of these. Let's see. So so in this case, you need to create it on a unique field or combination of fields. Okay, so there's more than what they're using here. So we'll create that on the primary key. So we'll just go ahead and copy that. So remember, with a composite primary key, this means because they have 4 fields in here, that means the combination of these 4 fields is going to be unique for every record in the section table. They couldn't just use one or the other because those can be duplicated, but if they use the combination, it'll work. So that's why we have to put those fields in there. Let's see if this even works. All right. Okay, so it ran it, and it took this long to create it. Okay, so here we can see it took 224 before the index and 216 after. So let's try it again. 291 before the index, 238. And so you may say, whoop-de-doo, you saved 30, 10, 100, 1,000, 10,000, 100. You saved 6 100,000ths of a second. Whoop-de-doo, right? Well, that's on a larger scale, that's much better. Oh, well then now here, look, it didn't go faster. There, it didn't go faster. There, it did. Yeah, this might be too small to even make a difference. So, I've only got 4 minutes before I have to go. Let's see. So, anyway, I'm not going to ask you to use indexes. The real point of this is just to know what an index is, how to create it, and what it's for. So, how to create it, okay? Whatever version of SQL you're using, you just look up the name of it, create index, and then you find the documentation, and there you go. That's how to create it in any SQL, right? What is it for? It's just to speed up queries, okay? The reason I'm talking about it, even if we're not going to use it, is because you may get asked this question in an interview. And even though maybe you don't have as much experience using them, understanding what it is really paints you in a good light. So don't forget. Here's your mantra. Indexes speed up queries. That's as simple as I can describe it. You don't even need to know why, even though this slide does show, it's a shortcut to getting to the record you need, basically. So anyway, if we added a lot, the more records we had in this table, the more it would work. And so I can't believe I haven't showed you guys this yet. Data generator, I think that's what it's called. GenerateData.com. So let's create a lot of records here to add to our database. Unfortunately, there's a lot of overhead on setting this up. So I think I might pause the stream for my meeting, and then I'll come back and finish this example, because now I'm curious if I can prove that the index saves you time. All right, so I'm going to pause the stream here. You can watch this later, it's fine. Not that one. Did I close it? GenerateData.com. So I'm going to add a bunch more records to the sections. Oh, Yeah, I'm gonna add a bunch of records to the sections table, and then we'll see if the index makes any difference on the query time. Okay, so let me pull up the database here. Oh, it was that one. Okay, and so this is okay. Let me just make sure it works still. Okay. So it has the time here. Okay, so we need to look at the create table code for section so that we can create a template for the generate data site. All right. So this is nice if you need to generate a bunch of records for testing. So you just put in the names of the fields, which is important that you match it. Oops. Otherwise it'll mess up. And so this one is varchar 8. So do it where we have data type here. And this is course ID, so we can just make that a number, randomly generated number. So let's go number range, and we want to make sure we don't enter any IDs that are the same as what's already in there. So actually, I remember now, we have to just set course ID, section ID, section ID, semester, and year need to be four-digit number for year, and then these are actually just strings. So we could just randomly put any strings in there. So let's just put names, and we'll put, this is just, it doesn't matter what we're putting in here because I just want to generate a bunch of records. So the section ID can be company names, the semester is characters. Well, let's make sure we don't enter anything too long. So if I go text, should give me fixed number of words. Nah. Okay, well, we'll just do that for all of these, because it'll just concatenate, or sorry, it'll just truncate any extra characters in the string. So we'll do 2 words for these. So what this is going to do is it's going to create an insert statement for the section table, and we want it to create it using SQLite. We already have the table created, so we don't need that. We're going to have inserts. By default, this will produce 100 records, and it puts them in 10. This batch size says it'll do 10 records per insert statement. So if you only want 10, you can just copy that part. Okay, we're going to insert those. And so now I'm just setting up the fields. So it's going to create for the course ID, it's going to pick 2 words and stick them together. For the section ID, the same thing, semester ID, or I'm sorry, semester. And then for the year, we can have it. I think year is in here. Date. And you just want the year. Oh, but they're storing it as an int, so we can just do a number then. Number range. So we'll do between the year 1000 and the year 4000. Okay. So, and we also have building. And we'll do words for that. And we'll do 2 words. We need room number. And that one has to be words. Right. Why does a room number need characters? Well, some rooms have letters in the room number. Okay. And then we have the last one is time slot ID. And that is also some fixed words. And we'll just do 2. Okay. That's everything that we need. Okay. And now we can generate those. You want to make sure you have the settings right, because I think it just gets rid of this page. It's really annoying to rebuild it. So, generate. Okay, so here are my 10 insert statements with 10 records each. And let's see if that works. So we'll throw those in right before we test our queries. All right, so that adds a lot of data to the database. The results are going to be huge. So let's see. So the first one, it says it took, oh, 1,000th of a second on this. And it took more time here. Let's try it again. I'm not sure how accurate this timing is. All right. Okay, I think I was looking at the wrong ones. All right, here we go. It looks like they're using lorem ipsum for the random words. All right. So the first one here took 7.5 hundred thousandths of a second. No, 10,000ths of a second. And this one took 8 10,000ths. So that did not go any faster. Let's try it again.
Echo. Stop music everywhere.
I forgot to clear it. So, oh, here it took. Oh, wait. Yeah. Okay, so that took 1,000th of a second, and that one took slightly longer. So there's a lot of other factors that are going on inside the computer while it's trying to grab this stuff. It's also trying to run itself. So you need probably a much larger example. Let's see if we can just find one. If not, we'll move on, because remember, the only thing that I care that you know about indexes is how to create one and why you would create one. Alright, SQL index example time. Squeezing performance from indexes. Okay. To return. I don't think they have an example with code in here. But they do talk about exactly what I was explaining about indexes. So if you want more information about that, I'll post this link. When was this posted though? 2017. I don't think much has changed about indexes in SQLite that this would be too old. So anyway, I'll post this and then we'll be done. If you're more interested in learning about indexes, you can check that out. All right. Well, you guys have a good day, and I'll see you next week.